Hello, it's Keith here, and this is lesson 11 of the platform-specific series of my 6502 assembly programming tutorials. We started looking at joysticks last week with the BBC. This time we're going to move on to the Atari 800 and 5200. Now this is quite interesting because usually when I'm doing two systems that are virtually identical, we'd just be looking at one piece of code. But unfortunately there is a rather major difference between the Atari 800 and 5200 in that the Atari 800 uses a digital joystick and the Atari 5200 can only use analog joysticks. This is the one time where the two systems are very, very different, and it really caught me out with Grime 6502 because I hadn't got code ready. I thought my code was going to work on both and it didn't. Fortunately, it was fairly easy to fix. So what we'll do today is we'll have a look at how we can make code that will work on the Atari 800 and 5200, reading from whatever hardware they've got. And we'll learn how we can make our game that will in the end compile to both systems just with a different joystick routine. Now, whatever the system we're compiling to, be it on the 6502 systems, Z80 or the 68000 systems, we're always compiling into the same format. And I've just got it up here. The format we're going to be using is a single byte for player 1 and a single byte for player 2. And we're going to use zero-page entries that I've defined as ZH and ZL, mimicking the Z80. And we're going to have one bit per button. And if the bit is 1, then the button is not pressed. If the button is 0, then it is pressed. And bit 0 will be up, and then we'll go down, left, right, 3 fire buttons, and start where available, of course, because most of the systems won't really have that much. But we're defining them in a common way, so our game will work in a common way on all our systems. Makes it a lot easier to port things as well, of course. So what about this Atari 800 and 5200 problem then? Well, as you may know, the Atari 800 and 5200, the addresses of a lot of the hardware are slightly different. This was apparently an intentional thing done by the bean counters at Atari because they didn't want people buying the Atari 800 games and running them on their 5200 because they were different legal companies or some nonsense like that. I really love that kind of thing. But anyway, what it means is they intentionally moved the graphics chips and things so that the games wouldn't work. In most cases, it's just an annoyance. But in the case of the PIA, which is the digital joystick reading hardware, it doesn't exist on the Atari 5200. So it's not that the port's changed, it's just gone. So the way the joysticks work on the 5200 is they're effectively analog paddles. And so we're going to be working with those and we're going to have to convert from analog to digital very much in the same way as we did on the BBC. So the code's not too difficult for us. It's just an annoyance that we have to have effectively two versions of our code. So how do we read in? Well, on the Atari 800, we've got two ports. We've got port A, which does joysticks 1 and 2, and port B that does joysticks 3 and 4, which we're not going to use in this. Now these hold up, down, left and right for each player. Port D300 is for player 1 and 2, which is all we're going to need, and D301 would be for players 3 and 4, but we don't do 4 players in these tutorials, so we're not going to look at that. Now on the Atari 5200, we can't get up, down, left, right in that way. We're going to be using analog paddles, and there are 2 ports for each pair of directions. So paddle 0 and 1 do up, down, left and right for player 1, and 2 and 3 do up, down, left and right for player 2. And one paddle port will do left and right, with the middle being not left or right, and the far left being a low value and the far right being a high value, and the same for up and down. So bottom left is near 0 and top right is near 255, very approximately. Now, despite the directions being read indifferently, we actually use common fires, so it all gets very confusing here. These are effectively part of the pokey chip, these analog reading routines, and of course there's no... And so we're reading in from hexadecimal C200 here and onwards on the Atari 5200. We don't use these on the Atari 800 because we've got these digital joysticks instead on that system. But whatever system we're using, the fire buttons are read in from the same thing, the GTIA. Now the memory addresses are different, but the functions are effectively the same. Bit 0 of each of these 4 addresses is the 4 fires for the 4 players. So let's fire up our example here. So here's our example, and if I press up, down, left, right, and then fire here, you can see that. And then up, down, left, right, and fire, there it is, for player 2. So we're reading in 2 joysticks here just fine. And here's Jum52, my 5200 emulator. And if we just go into the settings here and I just change this to a joystick. Up, down, left, right, and fire. But then my second joystick doesn't work because as far as I understand, Jum52 doesn't support 2 joysticks. So what we'll have to do, okay, so here's the Atari 5200 version, and you can see if I press up, down, left, right, and fire, and then on the second joypad, up, down, left, right, and fire. There we go. So we can work with both joysticks, but just not on that other emulator. So how does the code work? Well, we've got a command here called player read controls dual. This will read in the position of the joypads and the fire buttons and store them in 0 page defined entries ZH and ZL. And we've got this monitor HL function here, which just shows them to the screen. And then we've got a locate command here. And we're just repeating around this loop to show the values to the screen repeatedly so we can test our joystick. So let's have a look at the actual code that's doing the work. Now you'll see here there's two versions of the code. There's the Atari 800 version here and the Atari 5200 version, which is a bit longer down here. So how do we do things? Well, of course it all comes down to those ports. So on the Atari 800 we're reading in from port D300 here, and the bottom nibble will be player 1's up, down, left, right, and the top nibble will be player 2's. And you can see that represented here. So what we're doing is we're loading in. We're using the PIA address here. This is defined in the header. You can see we've got these definitions of all of the devices because remember they do appear in different positions depending on which hardware we're using. Now of course this joystick routine is specific to the Atari 800, but just for consistency I tried to use it everywhere just in case I copy a bit of code somewhere else later on. So there we go. So we're taking the bottom nibble for player 1. We're setting the top 3 bits to 1 because we have no fire buttons or any other kind of button to use there, and we're temporarily storing that in ZH. Next what we're doing is we're loading in the fire button, which will be in bit 0. We're rotating that 4 bits to the left. We're then ORing in the value we have here, which was stored in ZH, and we're storing the result back into ZH. Now if this use dual joy definition is defined, then we're going to use 2 joysticks, and so what we're doing now is we're doing the same for the second player. Now we're going to load in the fire button of the player first this time. We use GTIA plus hexadecimal 10 here. Now you can see just here that that will be D010 effectively. Now we're using D011 this time for player 1, and we're rotating to the right, pushing the bit out of bit 0 for the fire button. We're backing up the processor flags onto the stack here, and then what we're doing is we're taking the top nibble of PIA plus 0 again, which is the player 1 and 2 controls. So this time it's the top nibble we want, and that's why we've done it in reverse, loading the joystick fire button in first this time. Now we want those top 4 bits, and we're rotating them right here, but because we've got the fire button state in the carry here, when we do this rotation we're effectively pushing the carry into the 4th bit just here, and so we're conveniently rotating our 4 controls up, down, left and right into here, and our fire button into here, and so that's just saving a little bit of memory here rather than doing it in this order where we'd need more rotates. Now if the joystick is disabled, joystick 2, then we're setting all the bits to 255, effectively just disabling that joystick, but making sure if our code is reading it, it will think the buttons aren't being used, which is going to make things work nice and easily. So that's the Atari 800 version. Fairly straightforward really. We've got digital joysticks read in from the PIA, and then we've got the fire buttons read in from bit 0 of the GTI addresses, and of course the addresses just depend which joystick we're reading in, joystick 1 or joystick 2. There are of course joysticks 3 and 4, but most games aren't going to need those probably. So what about the Atari 5200? Well, the fire buttons are read in the same way of course, but everything else is unfortunately different. So what we're doing here is we're loading in the fire button first, and we're storing them in ZAS, which is another 0 page defined byte here. We're using this as a temporary build byte, and we're loading the fire button in first for the same reasons we did with player 2 here, because all of our later bits are being shifted in, and they're being done by this read controls process analog command. This is a function we're going to look at in just a moment. What it does is it reads and converts an analog direction into a pair of bits, which we can use in our basic up, down, left, right, fire routine, so because we just want a single bit for those directions. So we're loading in from the POKey here. Now, as we saw here, POKey address 0, which is going to be C200, is game paddle 0, which is the first direction, and that is going to be left and right. And then C201 is going to be up and down here for player 1. And these are going to be the same for player 2. So you can see here, we're loading C200, C201, C202, and C203 here for the directions of the two game paddles. And each time we're using read controls process analog here to convert that analog value from the address in the accumulator into a pair of bits which will be shifted into ZAS here. Now we'll look at read controls process analog later, but you can just take it from me, it will have pushed in 4 bits, which will be the direction bits. What we then do is we're setting the top 3 bits to 1 here, because we have no joystick fire buttons for those, but we need them to be consistent. And then we're storing that in ZH for player 1, and then we're doing the same for player 2 here, but this time we're using GTI address plus hex 11 for our fire button, and we're using Pokey plus 2 and Pokey plus 3 for the analog paddles. But essentially the routine is the same, this time storing in 0 page entry ZL. If the second joystick is disabled, which we may want to do to save memory, then we are just loading in 255 again. So really all of the work is being done by this read controls process analog, and let's have a look what that's actually doing. Well, before we ran this routine, we were loading in from one of our addresses within the Pokey for our analog value, and what we're doing is we're comparing to what we're defining as the dead zone, which is the center of the stick where we're ignoring any kind of small pushes to the left or the right. Now on the Atari 5200 I found a dead zone of 128 works quite nicely, so any value less than 64 will be considered left or down, or any value greater than 192 will be considered up or right. And so you can see here we're doing comparisons with those values here, and then we're jumping to either this low command, which will set a bit to 1 and a bit to 0 and rotate them into ZAS, which was our build-up value here. Or if it's high, then it does it the other way around. Now if the joystick is still within that dead zone, then it's setting both bits to 1, which means neither direction is pressed. Now you can see here I did have some code to do that in a fairly straightforward way, but I've put a branch here just to save a byte or 2 here. And that's really all it takes to convert the analog values into digital values for our joystick control to work in the same way on both systems. And so that's got us around the problem of the Atari 5200 and 800 working in quite different ways, which was quite frustrating. And this joystick code was used in my Grime 6502 game, which of course works on all the 6502 systems in my tutorials, and both the Atari 800 and 5200, and that was because the code, I have different versions for both systems, but 90% of the code for both machines is identical. So if you do the kind of things I've shown you in here, you will be able to write games that you can compile for both systems if that's what you need. Anyway, I hope you found this lesson interesting. As always, there's text documentation on my website and you can download the source code. We're going to be continuing with joysticks and we're going to be looking at more 6502 systems, but we're going to be coming back to the Ataris later on to look at how to do other things that you're going to need to do if you want to write simple games on the Atari 800 and 5200. We are also going to have a look at the Atari Lynx later on, so please stick around for that. Thanks for watching today and goodbye.